So, hey, welcome to the first episode where we're actually going to get some stuff going. What we're going to do today is do a basic lab setup that's going to give us a pretty versatile platform for doing any type of networking and virtualization experimentation that we want to do. What we'll have going on here is an ESX server here, ESX, and we will have that we have an ESX server here with a management connection and a lab connection. So you will need two networking interfaces, or you could do a single interface with a trunk if that's the way you want to do it. But this is how we'll be doing it today. This is where we'll run our virtual appliances. They will all have connections to the lab network and the management network. And then we have 4 switches. These are multi-layer switches, Cisco 3750Es. You can get them for a reasonable price on eBay. And we'll have a management PC connected to the management network, or a management computer. It doesn't have to be, it can be whatever OS you want. And that'll give you a setup. We can do pretty much anything you want. Mine is going to be set up for the INE, CCIE stuff. What'll be different about my setup versus what I see in most of the blogs is that I will not be using the console session over network connection that a lot of people do, or the named pipes. I'll actually configure mine to be connected via SSH, and I will be setting up the lab configuration to where when I load the INE configs, it will not override my management connectivity. And I'll be showing you how to do that as well. This will probably be broken up into several sections. One will be me setting up the ESXI hypervisor and actually loading the base appliances onto them with a base configuration. And then I will be showing you how I configure the devices and manage the configuration on them. So that's that. So let's get going. So if you want to know what I'm using as my server, I'm using an HP Z800. You can find setups for this thing with 96 gigs of RAM and 2 Xeon processors for 12 cores. You can find them for not such a bad price. So what I like about this box is it's not very large. It's very versatile. I can use it as a very beefed up like workhorse PC, or I can use it as an ESX hypervisor. It is perfectly compatible with ESX 6.5. And it's not loud. No matter how hot it gets, it doesn't get very loud. So that is very helpful. You can get an R710, a Dell R710 probably for less. So if we do R710 with 96 gigs, probably gonna find, yeah, you can find them for yeah, let's just put something in there. Yeah, so you can find it for a decent bit less, $450. Not that bad. Shipping's probably gonna knock your head off though, because it's probably a heavy beast. Now let's calculate shipping to, I don't know, random place. Yeah, that's actually not too bad for UPS ground. But anyway, that's that. So if you can tolerate an R710, or your wife can tolerate it, or whatever, roll with it. If not, if you want something that looks relatively inconspicuous, you can do something like a HP Z800 or any other workstation grade tower that uses virtualization friendly processors. But anyway, so to the nuts and bolts of it, I'm not going to show too much of the simple stuff. Basically, to create my ESXI installer disk, I went ahead and used something like unet bootin. So to create the ESXI installer disk, I used something like unet bootin. Just picked my disk image, and I have it on the desktop. Pick the ISO image, and then create the drive, which I've already done, so I'm not going to redo this. But basically, you just hit OK, create the drive. So now I'm going to set up the hypervisor. I can't do a screen capture on that because I don't have a capture card that can capture a remote monitor input. But basically, you'll just configure a management IP address and a default gateway for that. If you need to find out how to do that, I'm pretty sure someone's done a great tutorial and you can find that. So sorry for the lack of completeness on that one. But we'll be right back once we have the hypervisor up and running. All right, so now we're back in action. We got our server up and running. I've given it a management IP address of 10.99.0.250. So if you hit that IP address under HTTPS, you will be able to log into your new hypervisor. So we'll go ahead and log in and start configuring the basics of what we're going to need to continue building our lab. So right now, the only thing you have is your root user. Log into that. Never save passwords. All right. So let us first create ourselves a separate username, so we're not logging in as root. Let's see. So it should be under manage. Users. Add user. My doggy here, appropriately named Cisco, wants to get in on the action. So if you hear him snorting in the microphone, sorry about that. Alrighty. So we'll just use my name as the username. It's admin. Let's see. And password. Hey, buddy. All right. There we go. So now that's set up, we should be able to log in as that, configure everything. Alrighty. What? Maybe I forgot to do something. There's probably some ESXI expert out there. He's probably like, "Oh, you noob, you forgot to set the roles for your user account," or something like that. Let's see, users. User. See, this says I'm not authorized. That means what? What does that mean? I mean, how does... Probably doesn't have to do with this. But we're going to do this anyway. I'm pretty sure there's something else though. There we go. That's what it was. You gotta go to host, go to permissions, add user. Add this guy. I'm an admin. We're gonna add the user. And now we're good to go. See? Computers. Anyway. Bam. Now we're in here, so first thing we need to do is make sure we have adequate data store or storage pools. I'm going to leave this as is right now. I'm going to be installing the VMs on a RAID that I have set up inside of my host on this main data store. So it'll be fine. That's a RAID 0 solid states, and I know that's like, oh my gosh, it's gonna crash and blow up everything. It'll be fine. Just back your stuff up. It's just a lab, so I don't care, and I'd rather have the faster read writes of the RAID 0. For production, of course, you want to use something that's a little bit more robust. Networking. So we already have the default virtual switch set up. We are going to add a new virtual switch, and we'll call this the lab switch. And it's going to connect to VMNIC 1 because the vSwitch 0 is already connected to VMNIC 0. And they cannot share VMNICs in ESX. Blah, 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 blah. So we can actually do link discovery. We're just going to turn it off because we don't want it doing any CDP stuff. Security, we're actually going to allow all of these because promiscuous mode is going to be necessary for us to forward all traffic from all ports to all ports. And the reason why that is going to be important, if we pull this back up, is because all of these routers, the way we're going to segregate traffic between them is by using sub interfaces and .1q tagging. So they need to be able to see all traffic coming from all of the devices, including this switch. So this connection to switch 1 is going to be going to VMNIC 1. And then these are all going to be connected to that same virtual switch. So we can actually rename this lab vSwitch if you want to see what's going on. So all of these are going to be connected to the lab vSwitch. And since they're in promiscuous mode, all of them will see all traffic to each other, but they will only respond to traffic that is tagged appropriately with the correct .1q tag. If you're not familiar with that concept, just stick around or check out one of the later parts of the video or a later video where I show you how that works. And it basically allows you to create any arbitrary virtual topology you want without having to reconfigure vSwitches and reconfigure interfaces on the VM. So it makes management a lot more straightforward, makes things easy. All right, so anyway, we'll get rid of that for right now. So we have a lab vSwitch and our main vSwitch. And so what we'll do is go to port groups. You automatically start off with a VM network and management network. The management network is for the hypervisor itself. The VM network is for the default connection of all VMs. We're going to use that as the management connection for these. So you could think that all of the VM network connections are going to go out over this link. So we can even say this is VM network. And so all lab vSwitch stuff is going to go out over the lab network link. So that's our interface 0, interface 1, if you want to think of it that way. And that's going to make life easier to deal with because we'll have out-of-band management. So that means even if you blow up something on the configuration of your lab network, you don't lose connectivity to your VMs or to your switches. So you can always manage to get in there and fix it again. Because all of your management connectivity is out of path, technically, since you're using two different interfaces. All right, we'll go back here. So you got VM network, management network. We're going to add the lab network port group to that. Rock. All right, so the VLAN ID, I believe you can do 4950. Is that it? Hold on, let's see. Blah, 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 blah. Oh, 4095 is what it is. 4095, yeah. So we'll go here, 4095. And that's going to allow this port group and switch to be in promiscuous mode. We're going to set it to the lab vSwitch. It's going to inherit these settings from the lab vSwitch. We're going to do add. And now we have configured all of the hypervisor level settings necessary to start building VMs and getting them connected to each other. We're going to do one other thing though. And you don't have to do this part. I do this part because it just frees up more RAM. So if we go to System, Advanced Settings, and it should be mem paging. Boom, boom, boom. So if we do allocate guest large page, we're actually going to edit this option, set it to 0 so it's false. Scan time should be fine. And there is one for salting. We're going to set that to 0 as well. So what I'm doing here, by doing this, you see here it says pshare lets you limit the transparent page salting. Page sharing only between a set of VMs. So what it does is, if you have multiple VMs of the same type, they're running the same OS and everything like that. If the hypervisor sees any commonality between the information of the RAM, it'll actually deduplicate it and make them share the same chunk of RAM. Now that is great for memory optimization, but it is inherently less secure. So if you're running stuff in production and you have some guy out there who's a super amazing hacker and knows how to start screwing with stuff in your memory, it can actually cause things that is being affected in one VM to propagate to another VM that's sharing the same amount of RAM. So that's why they had the salting enabled, was to make it more secure so things like that won't happen. I'm turning that off though, because these are routers that are going to be running, and we're not worried about that kind of stuff happening in this environment because it's a lab environment. By setting the page size to small, or turning off the large page backing, that just allows it to look for smaller chunks of deduplication, from what I understand. If any of you out there who are watching this are like, VMware experts, and I'm saying something stupid, please feel free to mention it in the comments and go, hey man, that's wrong. This is what it's really doing, and this is why it has those outcomes. I'm more than happy to learn from other people out there. But this is just what I know works from how I've been setting it up before, and it gives me the results I need. So awesome. And like I said, this is totally for lab purposes, not for production purposes. So don't do this in a production environment, because this might not be best practices. So if you don't know what you're doing, don't do this in production. Okay. Now we're going to set up an NTP server, because it is good to have all of them set to a synchronized clock. The VMs by default, like the routers and stuff, will synchronize with the hypervisor's clock. So if the hypervisor is set using an NTP server, the VMs inherently will be accurate as well, and you don't have to configure a bunch of NTP stuff on them, which is awesome. So we're going to do that under time and date. NTP status enabled, but the status is stopped because we don't have anything configured. So what we'll do, we'll have it set to start and stop with the host, and let's just go to NTP server. If we go to pool, and we'll do North America, and we'll just copy the first three. Actually, I'll just do this. If I can not do stupid stuff on my keyboard. There we go. Okay, so we have our servers configured. Let's start it. Make sure it syncs up properly. You can see the time is already a little off. Yeah, synchronized up pretty well right off the bat, I think. Coolio. So now that that's configured, we'll get into the meat and potatoes of the setting up the two target VMs we're going to work with. We want to work with the CSR 1000V and the ESXI V9K. These two appliances work really well in the ESX environment. I've had a lot of fun labbing with them, getting things going. So we're going to get those set up.